Using mathematical induction, we're going to prove that the sum of the cube numbers is equal to n squared over 4 times n plus 1 squared. Using proof by induction, so we're going to use our 4 steps. Step 1, which is when n is equal to 1. We start with the left-hand side. The sum from r equals 1 up to 1 of r cubed is equal to 1 cubed, which is 1. And the right-hand side is equal to 1 squared over 4 times 1 plus 1 squared. So that's 1/4 times 2 squared, which is 4, which is 1. So the statement holds for n equals 1. The base case is true. Step 2 is when n equals k. We're going to assume the sum from r equals 1 up to k of r cubed is equal to k squared over 4 times k plus 1 squared. With our assumption in place, we move on to the inductive step, step 3, which is when n is equal to k plus 1. And what we want to show is that the sum from r equals 1 up to k plus 1 of r cubed is equal to k plus 1 squared over 4 times k plus 1 is k plus 2 squared. So starting with the left-hand side, we can split that sum up into the sum from r equals 1 up to k of r cubed plus the k plus 1th term of this, which is k plus 1 cubed. Now we can make our substitution because that is equal to this. So it's k squared over 4 times k plus 1 squared, and then plus our k plus 1 cubed on the end. Knowing that I'm trying to get to a k plus 1 squared over 4 at the end, I'm going to factorize out k plus 1 squared over 4. When I do that, what's left in this first term, I've got the k plus 1 squared, I've got the over 4, I need a k squared. And here, I've got 2 of the k plus 1s, I need a third k plus 1. And because I've divided by 4 out here, I need to multiply by 4 for those two things to cancel. So now I've got k plus 1 squared over 4 times k squared plus 4k plus 4, which is k plus 1 squared over 4 times this thing factorizes to k plus 2 squared, which is exactly what I wanted. That is equal to the right-hand side. Final step is step 4, our conclusion, which we must not forget to do. It's always a mark for the conclusion, so we must always make sure we include it. And the conclusion states that a mathematical induction, since the statement holds for n equals 1, and if it holds for n equals k, it also holds for n equals k plus 1, it must be true for all positive integers.